Greetings, mathematicians. We're going to be continuing our work here and finding LCMs and GCFs of a few more groups of monomials. So first, a little bit more information about what a monomial is exactly. We've used them for a little bit, but we haven't necessarily very clearly defined them. So a monomial is just an algebraic expression that has one term, and specifically in that one term, the one term can contain just numbers or just variables or products of numbers and variables. The key thing is that on those variables that there could be exponents, and those exponents have to be whole numbers. So remember, your whole numbers are 0, 1, 2, 3, 4, etc. So you have some examples here on the left: 7x, 25mn squared, 24y cubed z squared. Those are all monomials. On the other side, on the right, those are things that are not monomials. So this first one, the 7 plus x, that's not a monomial because it's more than one term. We've got that plus sign there. That makes that two terms. Same thing for the second one. That minus sign makes it two terms. The last one, that's actually three terms. Plus you've got another problem here. -2 as an exponent, that's not a whole number. Maybe this y cubed, maybe that would be like a 3 pi. Pi is not a whole number. The n squared, maybe that would be like n to the 1/2. That's not a whole number. So those are some other things that could happen that would make something not be a monomial. So again, the key thing is here that it has to be one term, could be numbers, could be variables, but the exponents on those variables have to be whole numbers. So we're going to continue with what we were doing before here, and we're going to find the GCF of several monomials. Now, what we're adding here is we're adding in these variables here. So we found things like GCF of 6 and 15, 20 and 36 before. Now we're adding in some variables. I am going to switch over to just a different view because there's not a whole lot of room for me to show writing here. All right, so starting with 6x, breaking that into 2 times 3, and we'll come back to the x in just a minute. The 15 I'm going to break into 3 times 5, and then for the x, similar to what we did before, making sure everything lines up nice and neat in terms of the like factors. And then for your GCF, we're looking for things that are common, greatest common factors. So they both have 3, they both have an x. Your GCF is 3x. Now, I didn't ask you to find the LCM here, but if you wanted to find the LCM, remember you take your GCF and you multiply by whatever columns still remain. So 3x times 2 times 5, LCM would be 30x. And then we would do the same thing with this next problem. Now, just like we did earlier when we were doing prime factorization with monomials, start with just the numerical part. So 20 is 2 times 10, 10 is 2 times 5, 36 is 2 times 18, 18 is 2 times 9, 9 is 3 times 3. Now, if you need to erase and kind of rewrite some things, you can do that, but typically you want to have a little bit of space in the first set of numbers for the 20 to make room for the 3's, and then move on to the variables. So for the top one, I've got x squared. For the bottom one, I have an x. And then for GCF, looking for things that are in both. So they both have 2 times 2 times x. So 2 times 2 is 4, so 4x. And then for your LCM, you're taking your GCF times any of the columns that are left over. So 3, 3, 5x. So 3 times 3 is 9, times 5 times x, and then that gives us 180x squared. If you're feeling confident, go ahead and try these next two, the 32y squared, 6x squared y, 7xy cubed, 28xy squared. pause the video, give them a try, and come back and check your work. If not, keep working with me here. All right, so for the next one, 32 is 2 times 2 times 2 times 2 times 2, and 6 is 2 times 3. Line everything up appropriately. In the top one, y squared, that's y times y. In the bottom one, I did reorder this a little bit. I put the y first just because it was easier to line it up with the top one, and then x times x for the x squared. Looking for things in common, they both have a 2, they both have a y. That's what I showed in the blue there. So the GCF is the 2y. LCM is the GCF, so 2y, times all of the extra columns. That's what I circled in the purple. So there were 4 extra 2's, so 2 to the 4th. There was an extra 3, an extra y, and 2 extra x's, so x squared. Put all that together, multiply that out. That gives me an LCM of 96 x squared y squared. All right, and then for this last one, 7xy cubed, 7's prime, so that just stays a 7. Writing out the xy cubed is xyy. 28 xy squared. 28 breaks into 2 times 2 times 7. I just wrote it in a slightly different order to get everything lined up with my top term. And then xy squared is xyy. Again, everything lined up real nice. Things that are in common, they both have a 7, they both have an x, and they both have 2 factors of y. So the GCF in blue there, that's 7xy squared. And then LCM, that's the GCF, times all of the leftover columns. So there's two columns, so 2 squared. And then there's a y column, so times y. Multiply all that out. LCM is 28xy cubed. And here we are now ready to do our very last problem with 3 monomials. Now everything works basically the same. We're going to start by finding the prime factorization of just the numerical part. So the 12, that's 2 times 6, and the 6 is 2 times 3. And then the 18, that's 2 times 9, and the 9 is 3 times 3. And the 36, that's 2 times 18. The 18 is 2 times 9, 9 is 3 times 3, so do your numerical part first, then do your variables. So we've got 3 x's on the top one, 5 in the second one, and 4 in the third one. Trying to keep everything lined up. The top one has 2 y's, the second one has 4 y's, and the last one has 3 y's. Finding the GCF first. Look for what all 3 have now. So now you're not just looking for what 2 of them have. This time you're looking for what factors do all 3 of them have. So they all have factors of 1, 2, 1, 3, 3 x's, and 2 y's. So our GCF is 6x cubed y squared. And then our LCM, remember that's your GCF, times any columns that are left over. There's a column for 2's, there's a column for 3's, there's 2 columns for x's, and there's 2 columns for y's, and then we will multiply all that out, and that gives us 36 x to the 5th, y to the 4th for our LCM. And then that is our last problem here in this section. So that's it for now. Bye.